All right, everybody, welcome to lesson number 3. The homework assignment for this, solving rational equations again. So these are just a little bit more challenging. Couple things to remember. Remember, whenever you are trying to solve something, whatever answers we get, we have to check and make sure that they're not extraneous solutions. So for example, for this first one, I know the only two possible extraneous solutions are 0 and -2, because that's what makes the undefined fractions. So when I solve, if I get those two answers, I'm essentially rejecting them. So let's take a look at what the least common denominator is, or the common denominator is for this question. So the common denominator here is going to be 4x times x plus 2. So for that first fraction, I have to multiply both 4 and the x plus 2. So I have 1 times 4 times x plus 2, all over this, which is really 4x squared plus 8x. I'm just going to do the quick multiplication here to make it easier for me to write. Plus, the second fraction is missing the 4 and the x, so I'd have 1 times 4x all over 4x squared plus 8x. The last fraction is missing the x and the x plus 2, so I'd multiply 3 times x plus 2, and I have this 4x squared plus 8x on the bottom. Now when I go through and solve this, I want to take everything that's in the numerators. That becomes its own equation. So if I distribute, I have 4x plus 8 plus 4x equals 3x squared plus 6x. So again, these are a little bit more challenging. More of them come out to be factorable and all that jazz. So if I combine some like terms, I get 8x plus 8. And move these to the other side, I get 0 equals 3x squared. I'm going to wind up having minus 2x and minus 8. To factor that, I need to use that AC method that we learned in the last chapter. 3 and 8 have a product of -24. If I have two numbers that multiply together that add to that, it's 6 and 4. So I have 3x squared minus 6x plus 4x minus 8. Just like last chapter, the order of the middle doesn't matter. Factor out 3x, so I'm left with x minus 2, positive 4, left with x minus 2. So I have two answers here. I have 3x plus 4 and x minus 2. Both equal 0. Now if I solve each one of those by setting them equal to 0, I get a solution here of x equals -4/3 and positive 2. Take a look at the next one. Least common denominator here, or the common denominator, whatever you want to call it, is 5 times x squared minus 1. I know x squared minus 1 because x minus 1, x plus 1 multiplies to that. So for the first fraction, I have to multiply a 5 and an x plus 1, giving me x squared minus 1. Second fraction, I have to multiply a 5 and an x minus 1. That gives me an x squared minus 1. And the last fraction, I have to multiply just this x squared minus 1 to top and bottom because it already has the 5. If I do that again, all the denominators don't matter anymore, so I'm just looking at the numerator. So I have this equation that's left. Signs are important, so watch them. So we wind up having 5x plus 5 plus 5x minus 5 equals 12x squared minus 12. 5's cancel. Move the 10 to the other side. So I have 0 equals 12x squared minus 10x minus 12. Everything there has a common factor of 2. So I have 0 equals 6x squared minus 5x minus 6. Again, AC method. What multiplies to make 6 and -6, -36. Numbers that I can multiply that to make -5, -9, and 4. So I have 6x squared minus 9x plus 4x minus 6. do my factoring out. 3x, leaving me with 3 times 2 makes 6. 2x minus 3 plus 2. 2x minus 3. So I have 0 equals 3x plus 2 and 2x minus 3, which gives me answers of x equals negative 2/3 and 3/2. Both work because they don't make the first fractions undefined. Next question. I know that x squared minus 25 is x plus 5, x minus 5. So the first fraction I'm going to multiply by x plus 5. The second fraction I'm going to multiply by x minus 5. And the last fraction I'm going to multiply by nothing. Now for this one I'm going to kind of do the shorthand version. I'm not even going to show the denominators here because we really don't need them. If I distribute, x squared plus 5x minus 2x plus 10 equals 50. Common mistake here is remembering that goes to everything. Combine your like terms, x squared plus 3x minus 40 equals 0. I get the minus 40 by subtracting the 50 to the other side. I see I get answers of x plus 8, x minus 5. So I get a solution of negative 8 and positive 5, but that gets rejected as it is an extraneous solution, right? Positive 5 makes this undefined. We can't have that. Negative 8 totally works, so negative 8 is my only solution to this problem. Next question. Now this one's a little bit more challenging. This would be like the most difficult level question I'd give you. So for this 9 minus x squared, I don't want it to be 9 minus x squared. The order there is different than what I have. I have x plus 3, x minus 3. So I'm actually going to change that middle sign to a subtraction, which allows me to change the denominator to be its opposite. That's what subtraction does. So now I know that that first term has to get multiplied by x minus 3. The middle term has to get multiplied by nothing. And the last term, the negative 3, has to get multiplied by x plus 3 to make it so that all the denominators would be the same. Do some distributing. 2x squared minus 6x minus 8 equals negative 3x minus 9. Add your terms. 2x squared minus 3x plus 1 equals 0. Do your factoring. 2x squared minus 2x minus x plus 1. 2x is common. X minus 1 is common. X minus 1 all equals 0. And then we have x minus 1, 2x minus 1 all equals 0. So my final answers here, well, they're going to be a positive 1/2 and a positive 1. Both work because neither make undefined values. If you could do that last one, you're in really good shape for this topic. One of the last things we did in class, we did an application problem. This people versus deer problem. That's what we're going to spend a little bit more time on in the next lesson, going through and figuring out some fun stuff like percents and all that stuff, but using this concept again. All right, so we've spent 2 days now on this, so I'm hoping at this point we're all comfortable solving at least the mid-level to higher level questions. All right, the easy questions, we should be killing it by now. All right, hopefully this video helps. Keep checking your homework through the videos here to make sure that we're all good. Don't just not check it. That's a waste of everybody's time. All right, see you tomorrow. Don't forget about your polynomial projects, your birthday polynomials. Use Desmos. All right, bye.